In this presentation, we are going to look at how to perform logistic regression with SPSS. The version of SPSS we're using is version 21, full screen mode advice for YouTube. The data set is called log disease. It's essentially about diseases. .save, and it's available at my website kobriendublin.wordpress.com. And essentially, the general structure of what we're going to do is analyze regression binary logistic. So just a quick discussion about the data set. It has a dependent variable, which is a binary variable, disease, 0 or 1, yes or no. We have some explanatory variables, age, sociostat or psyostat, sector, and savings. Now, apart from age, all of these are categorical variables, which is actually an important matter. Let's go to the data set there. There we have it there. So as you can sort of see here, that disease is a binary outcome variable. 0 means without disease, 1 means with disease. So two outcomes there. Hence binary logistic regression. We have a couple of other variables here. 0, 1, this is also a binary classification, savings. We have sector 1, sector 2, that's also a binary variable. And we have socioeconomic status as psyostat, so upper, lower, and middle. Okay. And we have age as well. And okay, so let's perform our analysis. So essentially what we're going to do is try to sort of predict the outcome of a disease based on these variables. Now, just as a quick remark, actually, we don't actually get a really sensible result using all of these variables. I'm going to come back to that later on. So I'm actually going to sort of cut this presentation a little bit prematurely because we need to discuss something else first. So I'm just going to sort of get this thing started. Analyze, regression, binary logistic. That's how we get going in the first instance. Select that. Now, what I'm going to do here is I'm going to just sort of reset everything. So our outcome variable here is disease, so that's our dependent, and that's going to go in there. Now we're not going to use the ID number, so just ignore that one. So we're going to use all the other ones here, and we're going to select them. Now, as I said before, a lot of these variables are categorical variables. Okay, so that's an actually important matter. So what we have to do is, from all the explanatory variables that we've selected, we have to sort out which ones are categorical variables and specify them as such. So what I said previously is that apart from age, that they're all categorical. So essentially what I've just done there is specified that these are categorical variables and that age is not a categorical variable. Now there's a couple of other options there, but I'm not going to come back to that. I'm going to sort of deal with that later on. So continue that. Now I'm going to put in enter mode, but essentially it's what I'm just sort of highlighting here first off, it is that there are a couple of different procedures for variable selection. And essentially what we could do is, like, rather than use all variables together, which we're going to do now, it's a very simple case, we could actually do variable selection procedures, just pick useful variables only. But anyway, that's for another time. So we're all ready to go here. I'm actually just going to quickly look at options, classification plots. I'll just select that for a bit of fun, and confidence intervals for the odds ratio, exp of beta of b. And that's actually quite a useful little outcome, or a little part of the output. So I'm going to continue that, and options now. So we have 196 cases, and that's good. We have, this is what how the dependent variable is encoded, 0 and 1. We have some categorical variables here, and there's actually just a typo in this. So we got there's a summary status account of 2, but that's just a sort of error. I'm going to leave it alone, but there you go. And so socioeconomic status, sector within city, sector 1, sector 2. So I'm going to sort of skip through this and sort of go down to the end, because there's a lot of material here that one would have to get through. This is a sort of a classification table of how well the model predicts the output. Now you can sort of see here that it gets 130 correct predictions of people without disease and 15 correct with disease, but we have two misclassification types. We have this, we have a false positive and false negative. So we have 42 and 9 there. So that's the false positive, that's the false negative. Or anyway, vice versa. So anyways, essentially it is 74% correct. Now, what we're looking at down here is the odds ratios. So essentially this is the coefficients here. This is what goes into the equation. Now, I'm actually sort of going to cut prematurely off here because there's a lot of a lot of not significant results and insignificant results here. So this is where variable selection comes into play. Essentially what I'm going to look at here though, so these are the estimates. Now when we construct a equation based on these estimates here, these b values, we will also have the odds ratios over here, and we have confidence interval for the odds ratios. And you can sort of see that there are only two of the estimates, age and sector, are the only significant values, the significant variables in for this model. And the confidence, or the odds ratio for age is 1.029, and with a lower interval, confidence interval bound of 1.01 to 1.04 as the upper bound. Likewise, 0.146 to 0.595. Essentially, one would simplify the procedure using variable classification or variable selection procedures. So this is actually there's quite a lot of useless material here. So once you do variable selection procedures, it clears a lot of it out, and that's the best time to talk about coming up with regression equations. Okay, that ends my presentation.